things to do. So I went through and I kind of started this problem already, but the way that you figure out, why is it so tiny? Um, the way that you figure out for the area of the sector or area of the sector, you want this guy, so you need to subtract from 160. Once I subtract from 160, then I can just plug straight into the formula. So I'm gonna get 245 over 360, which is gonna simplify to be 49 over 72 times 16 pi. 72 and 16 are both divisible by 8. So this will be 9, this will be 2. And then final answer here is going to be 98 pi over 9. Seems pretty easy. Now, if I go to this one here, keep in mind, this is the area that I'm concerned about. I'm not concerned about this one. I'm not concerned about that one. The only reason I'm going to use those is to find the overall area of this guy. And so to find the inside here, the inside angle, I'm going to subtract away 135 twice. So 360 minus 135 minus 135 is going to give me 90. So the area of the entire sector is going to be 90 over 360 times pi 7 squared, which is going to be 1/4 times 49 pi. Now, I want to subtract from that the area of this triangle. But notice, since it's a 90-degree angle, you can just use the normal 1/2 base times height. So I'm going to have 49 pi over 4 minus 1/2 base times height, which is going to end up being 49 pi over 4 minus 49 over 2. And that's my final answer. I can't combine them because this one has pi, so we'll just leave it like that. All right. For this guy, again, you want to start off by thinking about, okay, let me find the area of the whole sector here. And then subtract away the inside. So I want to find the area of the blue. Since it's a semicircle, it's going to be 180 over 360. Or you could also just use the area of a circle, pi r squared divided by 2. But the entire radius for this circle here is going to be 6. So I'd have pi 6 squared, and then subtracts from that the purple. That radius is pi 3 squared. So I end up with 1/2 times 36 pi minus 1/2 times 9 pi. 36 pi over 2 minus 9 pi over 2 is going to give me 27 pi over 2. And then I'm done. So again, you're going to want to consider these to be the same. For this question here, I would start by finding the area of the overall larger sector and then subtract away the blue, the inside. And so the radius of this, like it says, is going to be 12. The radius of this is going to be 8. And then I would go from there. Don't do 5. For 6 and 7, again, you want to think about, how do I find the area of the shaded? What you can do, a couple different options. You could jump directly into it, or we can subtract away these pieces here. So I would encourage you to think about, how could I get rid of the blue? Or what you could do is think about how you have a square here. There's a couple different options for this problem. I'm going to let you think about this one. For this guy, keep in mind, I'm giving you the area. And so remember, the area formula for these is area theta over 360 times pi r squared. So think about what you're given here. Think about what you're given and plug into the formula. You know the area, you know theta. You want to find r. So think about that and how you could solve that. For my other class, again, some hints I would think about. If this is W, then this is W over 2. Okay. For this, it tells you that if the diameter is X, you want to find the perimeter of the rectangle. So this would be X over 2, X over 2. And remember, tangents are equal. So tangents are equal. Keep that in mind. Tangents are equal. Think about that.